MCT4C, this is lesson 1.4, part A, day 5. And the 3-minute review goal is to determine measures of angles given a trig ratio and in right triangles. So this one here was what we did yesterday or last day, and this is from long time ago. This is from grade 10 stuff. We hope that you remember. So cos theta equals a half. You've got to remember, you got to see that as one of those special angles. This is one of the special triangles. We have to be able to do this one exactly. But I get started with a diagram. Figure out which quadrants this is. So which quadrants are the cosine positive? Well, cast rule. Where's the cosine positive? In quadrant 1, because all of them are, and in quadrant 4. So draw our terminal arms. But the thing is we've got to recognize what the reference angle here is. And if we look it up on our chart or reproduce the chart, do we have to do that every time? I hope not. We know that the reference angle is 60 degrees. Notice my diagram is not very good. That doesn't look like 60 degrees, but that's what it is. And this is from our chart. I didn't reproduce it. We've done that a few times. But you could have, remembered our triangles, right? A triangle like this. All right, if this is my reference angle, and I got the adjacent over the hypotenuse, the adjacent is 1, the hypotenuse 2, you'd have to remember that that is an angle of 60 degrees, okay? Either using the chart or using these triangles, you come up with a reference angle of 60 degrees. And that's going to give us our two solutions. One here, our theta one is 60, and the other one is in the 4th quadrant all the way around like that. Minus 60 degrees, 300 degrees. And in the second example here, this looks a lot like the trig we're used to from grade 10 and 11, right? We've got a triangle, and we want to find this angle theta. We just have to figure out, what trig ratio to write down, and then we can jam it into a calculator, I hope. Well, this side's the hypotenuse. Let me get a different color here. This side's the hypotenuse, right? This side is the opposite side, adjacent side. So opposite and adjacent, that's the tangent. Tan of theta is equal to 2.2 over 1.3. Calculate. No two answers, right? This is just going to be an acute angle. Calculator. Yeah, again, on my calculator, I got to get the answer first. 1.3. Get the answer first, then do the inverse tan. Inverse tan, 59 degrees. Dandy. That's the end of the 3-minute review. Now on to the lesson. The expectations to find unknown sides and angles in right triangles using Sohcahtoa and Pythagorean theorem. This is lesson 1.4a. There's actually 2 days on this section because there's some problems to solve. This is sort of like the more routine stuff, and then tomorrow we're working on problems. So find each unknown. In this one we want to find a side. So with respect to the reference angles, what are the given sides? Well, we want to find the adjacent side, right, next to, and this is the hypotenuse. So which trig ratio do we write down? Well, adjacent and hypotenuse. So adjacent and hypotenuse is the cosine. I write down the cos of 32 is equal to adjacent over hypotenuse. Now I solve this, right? How do I solve? Well, I just multiply Again, jam that into a calculator, and you get about 42.4 centimeters. Right? Over here, we want to find an angle now, right? And this is x, an angle, and this is the hypotenuse here. Opposite and hypotenuse, this is going to be the sine. So we got the sine of x is equal to 3.5 feet over 7 feet. I'm just going to pound that into a calculator. Maybe you see something going on here, I don't know, but let's just pretend we didn't see anything. Jam that into a calculator and you get 30 degrees. Well, that is one of our special angles. We should have recognized this. This is actually, if this is unit 1, this is 2 units, right? It's twice as long. So this is one of our special triangles. And had we had the foresight to see that, we would have been able to get that without a calculator. But oh well. Let's practice the grade 10 stuff anyway. Let's keep going. Remember, solving a triangle means to find all of the angles and sides. And usually when, we're given one in words, the first thing we got to do is draw a diagram, an accurate diagram here. So we want to solve triangle ABC, and it's given us a bunch of stuff, and we got to solve it, find all the sides and angles. So I'm going to draw a diagram, get us started. And we kind of got to be careful when we're setting this up that we don't mess up the sides, right? So I can't just go ABC wherever, because it's important which one is the 90-degree angle. See there it says angle A is 90 degrees, so I know A is there. The other 2 points don't matter so much, but now we can label it. Little c is 8.2 centimeters. Little c is this side over here, 8.2 centimeters. Little a is 11.3 centimeters. And this should be enough for us to solve everything, right? Well, what are the things that we still need to solve? Well, we want to find little side B. I'm going to leave that blank so we can find it. And we need to find the 2 angles. We want to find angle B and angle C. So I know I'm done when everything is written down, when this is full. How are we going to solve that? Let's find side B first. It doesn't matter. I could find an angle first, but let's find side B. Side B, I could use Pythagorean theorem, right? So 11 squared, hypotenuse squared is 8.2 squared plus a little b squared. A little calculator work here. I'm going to subtract 8.2 squared from both sides. You jam that into a calculator in one step, you get 60.45, and that's b squared. Take the square root of that, and you get about 7.8. Approximate answer here. All right, so here, that one's 7.8. 1/3 of the way done. If we want to just keep going in order here, angle B, we want to find this angle. Usually we don't like to use one of our calculators, just in case if we goof this up, we don't want to use this side that we calculate. Let's use the stuff that we were given to find angle B. So with respect to angle B, what sides are these? Well, this is the hypotenuse, and this is the adjacent side, so we're going to use the cosine, right? So we got the cosine of B is 8.2 over 11.3, and this is good old grade 10 review. We don't have to worry about the unit circle or 2 answers. We're just going to jam this into our calculator and everything's going to be great. What do we got? The answer's about 43 degrees. So that's our second answer. And notice we could repeat the process, use opposite over hypotenuse for angle C, but I mean, let's just use our brain here. We've got a triangle, and we know 2 of the angles. We can find the third, right? So angle C is 180, subtract the 90, subtract 43, and that works out to 47. Now that we've got all the angles and all the sides, everything is known, we are done.